Okay, so we started with classes with pointers and we stopped at destructors, if you remember. So today what we're going to do, this is the full example that we have on chapter 11, which is about the classes with pointers. So what I'm going to do, I'm going to walk you through the whole code. I'm going to explain to you destructors, copy constructors, and then we're going to look at the overloading the assignment operator. And once we do that, we're going to go back to the slides and skim through the slides if there is anything that we did not cover to make sure that it's fully covered. Okay? So if you do have any questions, please do interrupt me throughout the class. Okay, so the particular class that we're looking at is called the string variable, and in this string variable we have two private data members. One of them is the value. This is where the string will be stored, and this is a pointer to a character. Okay, so at one point in the instructor, as you know, we're going to do something like this. We're going to say that value is equal to new char, and then just give it the size, whatever that size is, right? So this is dynamic memory allocation as you know it. Now those values, this is a C string. This is not a C++ string, which means that it looks something like this. For instance, you have C, and then as you know, the last character, now just refreshing your memory, is \0. Okay, so those are C strings, not C++ strings. Okay, a C string is just simply an array of characters that ends with a \0. Okay, right. Now what we also have in this class, we also have another data member which is called the maximum length, or the size, call it whatever you want. Things can be a bit more complicated, by the way. You can add a third variable called number of items used. If you remember in programming 1, whenever you're dealing with arrays, you have two variables. One variable is called the size of the array, which is the maximum size, and the other variable is called the number of items used, because you can partially use the array. You don't have to fully use the array. Anyway, it's simplified over here. You only have two variables, which is the string itself, which is called the value. They could have called it a string or my string, but value is fine. And then there's the maximum length, which is the size. Now there's a number of constructors. This is a default constructor. We'll see what's happening there. This is a non-default constructor, and this is also a third constructor. In this constructor, we're passing it another string, and then we're copying from this string to our string, which is called value. How do you copy strings in C? Which function do we use to copy a string? strcopy, right? So simply we're going to use strcopy to copy from A to the value that we have. So this is the default constructor over here. What did we call this part? The initialization section. In the initialization section, we're initializing the maximum value to 100, which means that the maximum size of the string is 100 in this particular case. And then we're saying that value is we're using dynamic memory allocation. We're creating the memory for the value. Why do we need +1 over here? For the \0. Okay. And then what's happening at this line of code? We're just saying that this is an empty string. Now, if this was a C++ string, this is how we would declare an empty string, right? But in C strings, it's different. You have to say that, you know what, the first character that I have is \0, which means that this is an empty string. So this is the way to initialize a C string. Okay, then we have the non-default constructors. Let's see, what do we have? This is one non-default constructor. We're passing it the size, so instead of just 100, we're passing it as a parameter now, and the rest is the same as you can see it. This is a bit different because, which one? This one. We're passing it a C string, and we're copying it. Now, before we copy the C string, of course, we have to allocate the memory for value. But when we allocate the memory for value now, we're going to use the length of A. And how do we get the length of A? Do you remember the function which is called strlength? Okay. So now we're going to say that the maximum size is going to be equal to the size of A. So our maximum size is equal to string length of A. And when we allocate the memory for variable, for value, we're going to allocate it as such. We add 1 for the \0, and then we copy from A to value using the strcopy. Is there another way to copy from A to value instead of using the strcopy? We could have looped, right, and copy just one character at a time, because both of them are arrays. So you can just loop and copy as if you're copying two arrays. Okay. Now the third one is called the copy constructor. The fourth one is called the copy constructor. I'll come back to that. It's a bit needs a bit of more information. This is where we stopped last time. This was the destructor. When is the destructor called? Before that, the destructor has an arrangement. Couple of things. First of all, you can only have one destructor. You cannot have more than one destructor. We can have more than one constructor, right? Default, non-default, and so forth. With destructors, we can only have one destructor, and it always has no parameters. That's the first rule. The second rule is the name of the destructor is the same as the name of the class, but we also have to add this tilde sign, tilde wave sign, whatever you want. I think it's pronounced tilde. It's written tilde, but it's pronounced tilde. The wave sign, okay? So it's preceded by the wave sign, okay? In the destructor now, there's only one thing to do. You usually use destructors if you have pointers in your class. If you don't have pointers in the class, it's most likely the case that you don't need a destructor. Now we need a destructor over here because we used an U in the constructor, hence we have to use delete. And the appropriate location for the delete in this case will be the destructor. Whenever you have an U, you have to have the corresponding delete, right? But when is the destructor called? Do you remember? Whenever a variable goes out of scope. What does that mean? So let's now jump to main. Let's jump to main and show you what does it mean. Now let's assume that this is main, and then it's called string val. Is it capital S? String val is fine, and I'm going to initialize it with 10. No, I think a string with small s. Is it? What's the name of the class, guys? var. var. Not value, variable, and capital S. Right? Okay. That's it. This is my main. Now S is declared, this variable, this object is declared between those two curly brackets, right? Once we exit from this curly bracket, we say that S went out of scope. This is what it means. When S goes out of scope, the destructor is automatically called. You don't have to call it. And this is an attractive feature of using destructors in C++. It's automatically called when the variable goes out of scope. But let me give you another example where the variable can go out of scope. For integer I is equal to 0, and then I is less than 10, and then I plus plus, and then I'm doing a number of things over here, very complicated stuff. Now, what's the scope of S? This is called the block scope, right? In programming 1, if you recall, the smallest scope was called the block scope. If it's declared inside the loop or inside an if statement, this is called the block scope. The one larger is called the function scope. This is a function scope. Main is a function. It can be user defined function or main. It doesn't make a difference. Both of them are functions. And this is called the local scope. And the highest one at all is the one that is declared outside main, which is called the global scope, as you know. Okay. Now, S, when will it go out of scope? Once we finish this loop. Once we exit from this loop, S will go out of scope. And if S goes out of scope, what will happen? The destructor will be called. Okay? There are other cases where the destructor will also be called, but we'll come to them as we move on. Okay. Now the other thing that we have is something called the copy constructor. And the copy constructor, the way that it works is the following. Now let's assume in main that we've already declared a variable string var, and we called it string1, and we initialize it with 10 characters, and then we're going to assign it a value. I think there's a function over here which is called input line. So if you say just s1 dot input line, s1 dot input line from cn, so this will read it. So now we have a value for s1, okay, and then we're going to declare another variable now, string var s2, and what I'm going to do now is this. What's different about this declaration? We're calling the constructor, right? The constructor is being called. But what are we passing the constructor? We're passing it an object of the same type. Now, the other constructors that we have are the following. We have a constructor that looks like this. S3, let me call it S3, and then we can pass it AUS, for instance. Where did it go? And then we can pass it AUS. For this constructor, the following function will be called this function, because we're passing it a C string. We did not pass it an object. Okay? But for the other constructor, it's a completely different arrangement, because what we are passing it's an object of the same type. So we're trying to construct S2 with S1, and both of them, they have the same type. If you're trying to construct an object from another object, this is called the copy constructor. Okay? Now, before we look at the details, for this copy constructor, inside S1, we have a variable called value, right? And we said that value is equal to new char and then the size, whatever that size is. And now in S2, we're trying to initialize it using S1. This means that there are two things. There are two private data members in S1 that we need to copy to S2. What are they? We're going to copy value and max what? Max length, right? We need to copy both of those. The copy constructor just simply means copy all the private data members from S1 to S2. So we're just making a replica of S1. But now the question is, how can we copy value and how do we copy maximum length? Copying maximum length is straightforward because this is an integer. We know how to copy integers. But value over here is a bit tricky because it's actually an address of an array. So what do? Do we do something like this? S1.value is equal to S2.value. We know for sure that maximum length, this is straightforward because maximum length is actually an integer, so we can just say something like S1.maximum length is equal to S2.max length, right? This is not a problem at all because both of those are integers. Copying an integer is simple. But what do you think? Value, it's an address of an array. And if we write it this way, what are we copying? Are we copying the array or are we copying the address? We don't want to copy the address. And if we copy the address, it means that S1 and S2, both of them are pointing to the same array content, and that's a problem. We don't want both of them to point to the same array. We want to make a copy of the array. Okay? Now, just to let you know that if you do it this way, in C++, they call it a shallow copy. We're not interested in a shallow copy. Shallow copy, it means we're not copying the array, but we're copying the address. What we are actually interested in is a deep copy. So as opposed to shallow copy, there is a deep copy. Deep copy, it means don't just copy the address of the array, copy the whole content of the array. So how do we copy the content of the array? We either loop and copy one element at a time, but this is already done in the function which is called strcopy, right? So you can either use strcopy or you can copy one element at a time. The reason I'm emphasizing with this is that you might have a question which is similar to this, but instead of having an array of characters, you have an array of double. In an array of double, you don't have a function which is called string copy, right? So you have to actually loop and copy one element at a time. So we're not interested in a shallow copy. What we're actually interested in is a deep copy. So don't copy the address, copy the contents. So there are two things that we need to do. First thing is that the s1.value, we have to create it. So we have to say s1.value is equal to new character array, and then copy one element at a time from s2, as I'm going to show you in a minute. Yes, what's your question?
Sure. If you go into the main, we are assigning s1 as 10. If we put into this 10 characters without a slash mark.
Instead of 10?
In this 10 characters, we put 9 characters and 1 slash mark.
Backslash 0.
Backslash 0.
Yes.
Okay. So when we copy it into S2,
Mm.
in S2 it's adding one more.
Okay, let's see how is it being copied. Just a minute. So now we understand that we're trying to initialize S2 by copying S1. Copying S1, it means copy all the data members inside S1 to S2. Right. Now we know that for efficiency reasons, when you pass an object to a function, it's best to pass it as a constant reference. We agreed on this previously. Okay. So now let's look at the implementation of this constructor. This is the constructor, this is the copy constructor, and the copy constructor, as you can see, we're passing the object, this is object S1, we're passing it as a constant reference. Okay? So now the way that we called it is S2, and then we're passing it S1. So S1 is actually, it's called the string object in this case, okay? And we are passing it as a constant reference. But what's the type of S1? The type of S1 is string variable. Okay. What else do we have? Now in the initialization section, we're copying the length of the string object to the maximum length. Is there a function called length? There has to be a function called length. Here we go. So the function length will just simply return the string value of the string length of value. Okay. So now we're initializing the maximum length according to the you could, if you wish, over here. So let's write it in a different way now. Maximum length is equal to a string object. This is the parameter that we are passing, dot value, and then we take the str length of it, str length, and we could have done it this way. If this confuses you, then here we go. So the string length now is equal to the string length of the value of the object that we are passing. The string length of which object? The calling object. The calling object in this case is S2, right? Now we have S2 and S1, guys. The way that we are calling this is as follows. String variable S2, and we're initializing it with S1. Well, we repeated this enough times, you know that S2 is the calling object, right? So this maximum length, it belongs to which object, S1 or S2? S2, because S2 is the calling object. And this one in this case is just only a parameter. But the name of this parameter in the function is called string object. So now we're going to copy from the string object the length of the value. We're going to store it inside the maximum length. Okay? And then we're going to say that value of what? The calling object is 2. Value of the calling object is equal to a new character. Now this is where we're doing the memory allocation, and this is where we are copying from value of S1 to the value of S2. Instead of this, you could have written a loop, because if this was an array of integers or an array of double, you have to use the loop to copy all the elements one element at a time. What did we call this? Shallow copy or deep copy? Deep copy. But how can we make this a shallow copy? If we make this a shallow copy, just simply forget about all of this and just write that value is equal to a string object dot value. We're done. But this is not what we want. And if we do this, this is a problem, because this is not a deep copy. This is called a shallow copy. We did not copy the array, we copied the address of the array. So now we have two pointers referring to the same content. If you remember from programming 1, if you have two pointers referring to the same content, and you delete the content through S1, S2 will be pointing to garbage, right? you are pointing to a content which is already deleted. If there's a pointer pointing to a content which is already deleted, what did we call that? Dangling pointer problem. Okay. Control Z, so this is not what we want. What we are interested in is a deep copy of the actual array. Right. So now this is called the copy constructor. The copy constructor is always a constant reference. You send it another object of the same type, and you do a deep copy, not a shallow copy. I cannot emphasize enough. Okay. So up to this point now, I think we can run the first part of the code. But let's look at the rest of the functions that we have. The rest of the functions, they're straightforward. We've already covered before, but let's just skim through them for completeness. So there's a function called length. It just simply returns the string length of the value. There's a function which is called input length, and what you pass it is cn. So the way to call this, you can just simply say s1 dot input length, input line, sorry, it's called input line, and you pass it cn. If you're reading from a file, you'll pass it the file handler, but in this case we're just reading from cn. Input. Okay, so now again this is just a revision. If you're using C++, you'll use the function which is called getLine, and then you pass it your string, and you say stop whenever you encounter a \0. Fine. This is C++ style, but in C strings is a different story. In C strings, what you use is something else. You use cn.getLine. Those are different functions, guys. And what you pass it the name of your string, and you pass it the maximum length, or the size +1, whatever it is. So C++, you use the function getLine. For C strings, you use the function cn.getLine. Okay? You know this, but just to refresh your memory. Okay, and then we have an overloaded operator, which is the cout. So cout, in this case, the way to call it is just simply say cout s1. This is how this function is being called, right? So it's the same as saying, as we did last time, c1 dot operator put 2, and then what do we pass it? We pass it cout. Oh no, just a minute. Is this a friend function? This is a friend function. We don't call it this way. It's a friend function, so you just call it in a regular way. Just pass it cout, and then you pass it s1. The put2 operator, guys, it's not preceded by the class name. The put2 operator is always a friend function. A friend function is a non-member function. So this is a non-member function. There is no calling object. So this is how you call it. You just say operator put2, and you pass it cout, and you pass it s1. In C++, as we know, the thing about operator overloading is that you don't call them this way, you call them in a natural way. So you just simply say cout s1. But we understand by now that this is the name of the function, and this is the first argument to the function, and this is the second argument of the function, which is the string. Okay? We don't have time to repeat this, so I'm going to move on. We covered this last time. Okay. And then there's the operator equals to, the assignment operator. We did not see this yet, so I'll come back to it. Okay, so until now, what do we have is the following. We're going to test the constructors, the input and the output. So we have two variables. One of them is called two objects. One of them called your course, and the other one is called my course. Of course, you can have spaces in here. There's no problem with that. I'm going to ask you what's your course name, and then I'm going to read that from you, and then I'm going to print out your course. Operator put2 is being called at this point, right? Because I'm printing out an object. And then my course over here, operator put2 is being called because I'm printing out an object, and I'm done. In fact, there's straightforward. There's nothing to worry about over here. And then we have the copy constructor. Let's see what we have in the copy constructor. In the copy constructor, let's hide this. Okay. So we're creating one string and we're passing it test copy constructor, and then we're printing out the string type file. Now I need your attention. Is the copy constructor being called at this point? No, it's not. Okay. Now, look at what will happen. There's a function which is called showString. Is this a member function? What's your name? Razan. Razan, is this a member function? ShowString. No, it's not. That's correct. The answer is correct. It's not a member function because there is no calling object, right? So this is a non-member function. But there's a non-member function which is called showString. It's as trivial as this. ShowString, it receives an object of type string variable and it will just print it out. It cannot be more trivial, right? Okay, this is a non-member function. It has nothing to do with the class. So over here it says regular function programming one style. We're passing it an object and we're printing it out. Can we print out an object? Yes, we can, because we have the operator overloading, right? Okay. Fine. Now, we're calling this function, and what are we passing it? The object s. Now, the object s is going to be copied to the object which is called the string, right? Let me repeat that. When we call this function, I'm going to copy this to the top now. This is important, guys. This is how we call the function, right? But the string over here, is it a call by reference or is it a call by copy? Call by copy, which is also known as call by value, right? Which means that s is going to be copied to this string. We all agree on this, right? But now, believe it or not, when s is copied to this string, the copy constructor will be called. When you copy an object to an object using a function call, the copy constructor will be called. So now we understand that there are two ways in which the copy constructor can be called. The first way is the following. If you are inside main and you say that I have a string variable s1 and I'm going to initialize it with ABC, and then I have another variable which is called s2 and I'm going to initialize it with s1. And we agreed that this is a copy constructor, right? Okay, this is straightforward and we can understand. But there's another approach in which the copy constructor will be called implicitly, which is if you are passing your object by copy, not by reference, by copy. S1 is going to be copied to this string. You can think of it as following. This object, which is called this string, is going to be constructed using the variable s, which means that the copy constructor will be called. So now we're going to have a breakpoint to convince ourselves that actually the copy constructor is being called to copy s to the string. Okay, so I'm going to have a breakpoint over here now, and let's see what's happening. Debug, start debugging. This is the first part. It's asking what is your course, and your course is COE 221, whatever that course is. Now we created a variable called s, and this is what we have inside s. What does it contain? Test copy constructor. Can you see it? Now let's step inside this function. So I'm not going to step over, I'm going to step into. Where did it send me? To the copy constructor. Because now the variable, the parameter which is called the string, is being constructed using s. So as if what happened over here is the following. As if we're saying string variable and we're calling it the string and we're initializing it using s. This is what happened. Okay. Fine. This is S, right? Because we're constructing this string from S. This is S. S, it contains test copy constructor. Step in. Only now we're at the function call. And what's inside the string? Where did this come from? From the copy constructor. So two ways in which to call the copy constructor. In fact, there's a third one. It will come in a minute. Okay. So the copy constructor is not just always a explicit call. It can also be implicit.
So this is the copy of S.
This is a copy of S using the copy constructor. Okay. Fine. So now we're convinced that this is the case. I'm going to stop here. There's a third approach in which the copy constructor can be called. Okay. So now my book, your book, this is straightforward, right? We don't have strings, we have books over here. This is the two objects. Here's the third way. We've looked at this approach. Oh, there's also this one. Interesting. The copy constructor, this is the one that we have looked at. But here's also a fourth one, if you wish. If you have a function that retains an object and you're storing it inside an object, then the copy constructor will be called. What we have on the left-hand side over here will be constructed based on what this function returns. So if the function retains an object and you're trying to store it in the left-hand side, and the left-hand side is also another object, the copy constructor is called. But if you declare a variable using this approach, if you say string var s2 equals s1, provided that s1 was already declared somewhere else, the copy constructor will also be called. Okay. Now notice that later on we're going to do something like this. S2 is equal to S1. Those two lines are different. They're different because in this line this is a declaration line, but this is not a declaration line. Do you agree? How do we know that this is a declaration line? Because it starts with the object type. If you're using the declaration line, what is going to be called in this case is the copy constructor. If you do it outside the copy constructor, what is going to be called in this case is the operator equals to. Those are different. If you see the code in front of you and you're confused, you don't know which one is being called, just have a breakpoint and trace it. Did it go to the operator equal to, or did it go to the copy constructor? Right? We can trace it and figure out.
Can we just right click and view declaration? Will it show us which one it is?
No. You have to trace it. So, okay. Fine. So now let's go back to our point. So now we figured out that if you have a call by value, it's also called a call by copy, then this means that the copy constructor is called. Okay? Fine. Now, and again I need your focus again. Let's do the following. Let's trace this again. You'll love this, guys. You'll be surprised. I'll have a breakpoint over here and just run the code now. Start debugging. I started without debugging. Debug, start debugging, which is F5. Okay. Now we were in main, and main it already called the function which is the string, and the string it has the test copy constructor. We did this before, right? Okay. Now question: when we go out of scope, when we finish this function, which object will go out of scope? When we exit this function, it will be the question. When we exit this function, which object will go out of scope? The string will go out of scope. So if the string goes out of scope, what will happen? Let's see if this is the case now. So I'm going to print it out, and then I'm going to step in. What's this? The structure of which object? the string, which is the parameter, because the parameter went out of scope. Fine. It's deleted, and now we're back to S. Was S destructed? What was destructed? The copy of S, which is the string, right? So now let's do the following. But I think you'll get a bit more involved. Pay attention. Let us comment out the destructor. Comment out the what? So now there's no destructor. And let's repeat the same story again. Start debugging. CMP 120. This will print it out. Now we're going to exit from the function. This string will go out of scope, but there's no destructor, right? Fine. There's no destructor. And then we print out S, and everything is working fine. That's not what I wanted to do. But let's try it again. So now this is the call by value, and we're going to copy the S to the string. And then we have a destructor, and the destructor will destroy that. Oh, no. What I want to do is to comment out the copy constructor. That's what I wanted to do. So let's repeat the steps again. Keep the destructor, and the copy constructor. The copy constructor was implicitly called, right? So now we're not going to call the copy constructor. Keep the destructor though, we need it. Copy constructor. This is the copy constructor, comment it out. Okay, so now we don't have a copy constructor. Okay, now let's see what are the consequences. If there is no copy constructor, then S will still be copied to the string, but it will not be a deep copy, it will be a shallow copy, which means that both of them will share the address of the same array. In shallow copy, guys, what will happen is the following. We have the string will just simply C++, this is what it will do. It will just say that this string is equal to S, because this is a call by copy. If there is a copy constructor, the copy constructor will be called. So if there is a copy constructor, what will happen instead is this. And this is a deep copy. If there is no copy constructor, what C++ will do, just simply do this. Now when C++ does this, the consequences are the following. The shallow copy, guys, the shallow copy, it means that it's an element-wise copy. So what we'll have is the string dot max length is equal to S dot max length. And what it will also do is that the string dot value is equal to S dot value. Hello, we agreed that this is a shallow copy because we did not copy the elements of value, but we just simply copied the address of value. Okay? This is called an element-wise copy. It's also called a shallow copy. If you don't have a copy constructor, then C++ will do this. It will not generate an error, it will not generate a warning, it will just do this. Fine. Now, in our function call, so now let's take this to the function call. In our function call, this is what happened. This string was actually copied, made a shallow copy of S. At this point, C++ will call the destructor, right? So it's going to destruct. Where's the tilde? It's going to destruct this string. When we destruct the string, what will happen inside the code? It will delete value, right? The code inside the destructor will delete value. But now we made a shallow copy, which means that both s.value and the string dot value are referring to the same array. And this same array we have already deleted through the destructor. So now when we come back from this function, C++ called the destructor and it deleted the array through the string, which is already also pointed to by s. Which means that after this function call, if we try to print out s, what will happen? Junk, garbage, dangling pointer problem. Let's see if this is the case now. It is the case. Start debugging. No. Look at this, guys. This string, local variables. Let's go to watch, and I'm going to add over here the string, and I'm going to add s, but s is out of scope. We cannot see it now. Let's take it one step back and have it over here, the breakpoint. Start debugging. And now we have variable called s. I just want to take a note, guys, of the address of value. Value, this is the address of it, and this is the content, right? This is the pointer, this is the content. Value, the name of the array, contains the address of the first element. We agreed on this, we repeated it so many times. Remember, the name of the array contains the address of the first element inside the array. The address of the first element inside the array, in this case, what does it end up with? Make a note of this, please. BF0. Not BF chunks, BF0. Now let's go to the function call. This is the function call, and its s is already copied to the string, right? Look at the string, what does it end up with? So we did not make a deep copy. This is a shallow copy because we commented out the copy constructor. The value of the string and the value of s now are the same. We copied the address, we did not copy the content. Fine? Now let's continue. We're going to print out, after printing out, what would be called? Destructor. Let's go to the destructor. And now, surprise, surprise. What happened to s? Garbage, right? Both of them are garbage. So we didn't delete s. We did not delete s. So now if we print out s, at this point I'm going to try to print out s, and you get this beautiful outcome over here. So whenever you have pointers, you have to have a copy constructor. Whenever you have pointers, you have to have a destructor. Because the copy constructor is not just called when you're constructing an object, it's also called when you have a call by copy. Okay, so now we're convinced that this is the second case. Okay.
So what happens if we have a copy constructor and we have a shallow? It will copy it?
What's the point? The purpose of a copy constructor is to have a deep copy. If you have a copy constructor that does shallow copy, then there's no point having it. Yes? Let me make sure I understand your question. Let's go to main. Now let's assume that I have a function called function returns an object. This is the name of the function, okay? There's a function that returns an object. This is an important question, guys. String, and then I have string var s1 equals. Let's assume that I have a function that returns an object of type string var. What will happen, guys, at this point is that it's as if we're doing the following. It's as if we're saying s1 and we are passing it. Well, this is the nice way to think about it. It's the first time I write it this way, but this is what's happening. String var. This is what's happening, guys. Is this a copy constructor? It is a copy constructor because this function returns an object of the same type. So if you write it this way or you write it this way, in both cases the copy constructor is being called. But again, I would like to emphasize that this will happen. Okay. So those two are the same. Yes, what's your question now, Salma? Which function? This function, but this function did not take any parameter. So there is no object to be destructed. Unless inside this function you created an object, and at the end of the function the destructor will be called. But before the end of the function you have returned the object, and when you return the object you made a deep copy of it, and then the original object inside the function will be destructed, but you don't care because you already made a copy of it using the copy constructor. Okay. So now again back, if you go back to the slides, we know that if you have a function and this function it returns an object and you store it on the left hand side, then the copy constructor is called. We also know that if you have a function that takes a copy, what is it called? Call by copy, then the copy constructor will also be called. But guys, I just need another 10 minutes of your time. Okay. Now the assignment operator. The assignment operator, well, it's not a big deal. We know how to override operators, but the operator that we need to override in this case is the assignment operator. So how do we call this assignment operator? Just like what we did previously. S1 is equal to S2. No big deal, right? And this is a member function, so we can also call it by saying S1 dot operator equals to, and then pass it S2. Yeah, we did this before. So S2, we pass it as a constant reference, right? And then what will happen now inside this, what we need to do, whenever you have an operator equals to, you need to do a deep copy. It's never a shallow copy. It's always a deep copy, which means that if you have an array, you have to copy the content of the array, not the address of the array. Right. So now we start by saying that the new length, we have a variable called the new length, and it's equal to the string length of the right side. What's the right side in this case? S2, right? Because S1 is equal to S2. So the right side in this case is S2. So now we find the length of the array inside the right side, and then now we ask the following question. The new length, is it greater than the maximum size that we already have in S1? Because when we call this, we have S1 is equal to S2. Now, there are two cases over here that we have to consider. The first case is the length of the string inside S2 might be smaller than the length of the string inside S1. If it's smaller than, there's no problem. We can just copy it. But if the length of the string inside S2 is larger than the length of the string inside S1, can we copy a larger string to a smaller string? No, we cannot. So what do we need to do in this case? We need to create a new one. So we need to deallocate the old one and create a new larger string. So if my original size was 5 and I need to copy 10 characters, I have to start by deallocating the array and creating a larger one. When do I do that? I only do that if the new link, which the one that I'm copying from, is larger than my current link. And if that's the case, then I have to start by deallocating my array and creating a larger one, and then I will start copying. Now let's assume that the size of the string inside S2 was smaller. So in that case, we don't need to go through this if statement altogether. And what we do is just simply we loop and we copy just one element at the time. We could do this, or we could just simply use the function which is strcopy, right? So what we can do, we can just loop and now copy one element at a time, because this is an array, and then at the last element we just add the backslash 0. Instead of all this, you can just simply use the function which is strcopy. But it's fine to have it this way, just to let you know that sometimes it's not an array of characters, it's an array of numbers, which you have to copy it explicitly. So there are two cases to consider in this function. One case is the length of the string inside S2 is smaller than the size of the string inside S1. We have nothing to worry about. Just copy from S2 to S1. The other situation is the length of the string inside S2 is larger than the length of the string inside S1. In this case, we have to deallocate the value inside S1, and we have to create a new larger array and then copy to it. Did you get it? Right. Now, what's the return type of this function? It's void. It doesn't return anything, right? Right. So now we can do this. We can say that S1 is equal to S2. That's fine. But can we say that S1 is equal to S2 is equal to S3? Right. Now when we say S1 is equal to S2 is equal to S3, in what sequence are they going to be copied? What is going to be copied first? That's the question. Oh yeah? S2, S3 is going to be copied to S2. This is the first thing. The assignment operator, guys, they call it right associative operator, which means that you start copying from the right. Did you hear the term right associative operator in mathematics? Right associative and left associative. Right associative, it means that you start from the right. So now S3 is copied to S2. What will happen next? Pay attention to this, please. That's important. What will happen next, guys? S3 is copied to S2. What will happen next? S2 is copied to S1. So S3 is copied to S2, and what will happen next is this. Pay attention, please. Do you agree? Yes, you agree. Of course you agree. Now this is S3. What happened first is this. So now both S2 and S3, they have the value of S3. Fine? And then the second step is this. What did this function return? It returned S2. Yeah? And we mentioned that this is the first step. S2 is equal to S3. What's the second step? S1 is equal to S2. Which means that this function call, what did it return? S2. What's S2? S2 is the left hand side, right? The S2 is the left hand side. S2 is the left hand side of this function call. This is a function call, guys. This is the left hand side, which is the caller object, and this is S3, right? This would return the left hand side. The left hand side, it's a caller object, right? Because in fact what this is it's 2 dot operator equals, and we're passing it as 3. This function should return the calling object, which is S2. This function will actually return the calling object, and then the calling object will be assigned to S1. The point is, if we make it a void function, then this is the only case where we can cater for. But if we make this function return the calling object, then we don't have to worry about it, and we can just call it in a natural way. S1 is equal to S2, S3, S4, S5, it can go on forever. But now the question is, how can we return the calling object? And now look at this function. Where's the calling object? We have value, we know that value belongs to the calling object. Where's the calling object? How can we return the calling object? So we have to return the calling object. And the question is, how do we return the calling object? Okay, you don't know the answer. You should not know the answer. C++ has a keyword, built-in keyword, which is called this. It's called this. And this is actually a pointer or an address of the calling object. There's a keyword which will come out in blue. It's called this. It's the calling object. But it's not the calling object, it's the address of the calling object, right? Okay. So now let's assume I'm going to modify this function now, and I'm going to say, look, instead of returning void, I'm going to return something of type string variable, because I need to return the calling object. So at the end over here, what do I return? No, not this. I dereference this, because this is the address of the current object. I don't want to return the address of the current object, I want to return the actual current object. So I don't return this, I dereference this. Dereference this, it means I'm not interested in the address, give me the actual object. Because this is a pointer, I'm not interested in the pointer. Okay, خلاص, we're nearly done. So now, let's put this as it was, void, and show you the other object. So this is the second version of it, and in the second version of this function call, if you want to return the calling object, what you have to do at the end is that you have to return this. So this is a keyword. As you can see, it comes out in blue, and it's actually the address of the calling object. Okay. No, we're not interested in the address of the calling object. We want to return it itself. So what we do is that we dereference this and we return it as dereference. Now by doing so, we can use S1 is equal to S2 is equal to S3. Now, I'm going to skim through this again next class, but now just to let you know, whenever you have pointers inside your class, there are three functions that you have to implement. And in C++, they refer to them as the big three. The copy constructor, the assignment operator, the destructor. Listen to this. If you need one of them, you need all of them. In fact, if you have pointers in your class, you need all of them. You cannot get away of using one without the other. We looked at an example. We commented out the copy constructor, and it crashed. If you need one, you need all. If you have a pointer, you need all. Those are called the big three in C++. Okay, so let me stop here. I'll answer your questions if you have any questions, and we'll continue.